Hello everyone, welcome to our lesson 1, form 1, the last topic, the electric circuit. Okay, so we want to see what is electric circuit in physics. Okay, this is our last topic of form 1, but in some schools it can be taught earlier. So let us look at what I've written here because my space is limited. What is an electric circuit? This is a complete path of flow of electrons. So it is a complete path of flow of electrons. Okay? What you can liken it is if you have seen in athletics people running 400 meters. Okay? There is somewhere they start, they go round on the lanes, and then they come back. So that is what can draw your attention and compare it to electric circuit. Electric circuit is a complete path of flow of electrons. So you can take people running as electrons. The lanes is the circuit. So basically you are thinking of things that we cannot see, the electrons, but their effect can be measured and we can talk of electric circuit. The attention is on flow of electrons. Okay, so that is already covered in electrostatic 1, where you deal with the electrons, the negative charge and the positive charge and the neutrons. It is only the negative charges that can move. But I will remind you later, not at this stage. At this stage, our focus is what is an electric circuit? A complete path of flow of electrons. Then the second part we are looking at here is parts of the circuit. Having known what is an electric circuit, then what does it consist? What makes up an electric circuit? It consists of a source of electricity. There is a source from where we shall have electrons flowing. So that one we call a source of electricity. In our homes and in school, you will come across a cell. Okay, that is a cell. It also consists of conductors. In our case, conductors are wires, just the ordinary wires. They allow electrons to flow through them. So we say they are conductors. 3, a control device. A control device is also known as a switch. When it is switched on, the path is completed. Therefore, the electrons can flow. Then we also talk of the load. What device consumes the work done by the electrons so that it also changes that to another form? A load is a device that consumes the current. Okay? Current is flow of electrons. So we will see the pictorial diagram which should bring us or make us transist to the conventional diagram. Remember, we are dealing with electric circuit. And these ones are simple, by the way. They are simple. They are not complex. They are simple electric circuits. The circuits that we come across every day without realizing. Now we want to bring your attention to the right way of drawing them. So here I have a wire which we will be drawing them, not necessarily bending, but again it is agreed we can represent them with straight lines. So this one, the way I have drawn, it should draw your attention to a cell. You have a cell. The picture of a cell, not the symbol of a cell. So this is a picture of a cell. So when we see the picture, we can easily connect, and then we transit to the conventional way of drawing the apparatus. So this is a cell, this is a wire, then this is what we call a switch. As it is open. When I bring this here, then I connect it. Then there is another wire. You can tell this is a bulb. You can see a filament here. And then from there is another wire taking us back to the cell. So this is a picture diagram with a switch in an open position. The switch is an open position, so you can't see the effect on the bulb. Which effect? The effect of flow of electrons. Remember we said, what is a simple circuit? A simple circuit is an electric circuit which is complete path for the electrons to flow. So there must be a path for electrons to flow. That path must be complete. Where they started, they have to come back. An example in life, the athletes running 400 meters. And there are so many other examples. So when the athletes start at the sounding of the bullet, they run, go round in the lanes, and then come back. That is as simple as that. So those athletes are like electrons. Okay? They have to go and come back. The lanes is like a conductor. They pass through. So here we have a pictorial diagram. The diagram showing us the pictures of various components. Pictures of various components the way we see them. But physics demands that you draw them in a conventional way such that it does not confuse any student anywhere on earth. So we have the conventional circuit. This switch in open position is the same thing I'm showing there again in open position. This is open position. This is open position. On your right, you can see a bulb, picture of a bulb, but symbolically, this is the way it is drawn, symbolically. Then here, we have the picture of a cell, but symbolically, we draw it this way. And the longer side is positive, and then the shorter side is negative. So, this is what you expect in the lesson, the electric circuit. So this is the electric circuit, which represent the pictorial circuit. We need to know which symbols are used for various devices. As I conclude, what have I covered? 1. What is an electric circuit? It is a complete path of flow of electrons. You can paraphrase it. It is a network of wires. It is a network of conductors, which we call wires. We have the load, like here the bulb is the load. When electric energy gets there, it is converted to light energy. Okay? Have a switching, a control device known as a switch, and also we have a source. We must have a source which initiates the movement of the flow of electrons. So when those electrons flow in a path which is complete, then we talk of electric circuit. Electric, because we have cross-country circuit. We have different circuits. The bottom line, it is a path which is complete in one way or the other. Then we have seen the components of the circuit conventionally, how they are drawn, and the pictorial form. So what I want you to do after this lesson, try to write maybe 4 or 5 symbols of electric devices that we may use in future other than the ones I have shown. I've shown you the symbol for a switch, for a bulb, for a cell. Okay? Till then, bye-bye, folks.